and you practice modeling them over and over again. And that way, when you need to build a bracket for your shelf that's fallen down, or you need to build a thing that goes, I just built something here. You notice there's no keyboard here because I drew up and 3D printed a little bracket underneath to hold my keyboard on my desk. Like whatever it is that you need, whatever new bracketry or item or hinge or whatever it is, cup holder for in the car. Well, now you've got all that experience practicing, and you can kind of visualize that, and you can kind of hand sketch it up yourself, and then you can turn it into a 3D model, turn it into a 3D print, and you're good to go.
Hey everybody, welcome to Shop Talk, the podcast series where we talk to inventors, makers, and designers and engineers from shop to shop. Today we're talking to Too Tall Toby, who is telling us about his platform that has gamified CAD learning on it. He's really enthusiastic about this topic. He's got a passion for bringing CAD knowledge and experience to everybody from a noob to a seasoned veteran, and spreading the word about this important skill. So let's dive in. All right, we're here with Too Tall Toby. How's it going, man?
All right, Jonathan, thanks a lot. Great to see you here. Welcome to the world of competitive CAD eSports.
I'm stoked, man. I think our audience is really going to be interested in this one. First things first, how did you get to tootalltoby.com? I looked at your bio a little bit. I'm sure the 10,000 support cases you closed as a trainer reseller. That's the impression I got from what you were doing before. Anyway, I'm sure that helped a lot. But I'm curious about that journey going from doing this kind of working in a company, training people that way, to doing your own thing and all the cool stuff from your platform now.
Yeah, I mean, let me answer your question with a question of my own. What do you think is the best 3D CAD system?
I'm a little biased, but I think the best 3D CAD system is Fusion.
Right.
Yeah.
I mean, in tech support, so like you said, I did tech support for a number of years. I've closed over 10,000 tech support cases. It's definitely my bag. It is my favorite thing to do, to work with customers who are stuck and to help them get unstuck, and to hear a brand new challenge, a brand new problem, and to try to work with them and kind of figure it out. Every day was unique, and I loved it. But one of the questions we would regularly get would be, what's the best CAD system out there, right? Yeah. And there's not really an answer. They all have their strengths and weaknesses, especially when you get into kind of the individualized disciplines. You'll have a product like Revit that might be better for architectural or civil engineering, and then you'll have a product like Fusion that might be better for mechanical engineering. There's all these different products out there, and they all have their strengths and weaknesses. And ultimately, what I would always say is, it's not so much about the wand as it is about the wizard. It's like the person that's running that CAD system, if they're really good at Creo and you cut them loose on Fusion, give them maybe a couple of months, they're going to be an absolute beast on Fusion. Right. There's just like that certain personality type that really resonates with this idea of visualizing things in 3D and looking at something in the real world and turning that something into a 3D model. And so what we set out to do on Too Tall Toby was create those wizards battles, find out what it looks like to get all those wizards together in one spot and to create these battles. And so we created the world's first, multinational, global, CAD agnostic CAD speed modeling tournament. And so we got users from all over the world using all different CAD systems. We brought them all together. We pitted them against one another, 1v1. And we said, take this drawing and turn it into a model. And let's see how quickly you can do it. And if you succeed, you move on in the tournament bracket. And if you fail, then I'm sorry, you're bumped out. You'll have to try again next year. And ultimately, this left us with one single champion, our very first champion in the CAD vs. CAD tournament. It was a SolidWorks user, Ivan the Reasonable. Shout out to Ivan. He still hangs out with us in the community, and it's awesome to see his commentary and his thoughts on the world of 3D CAD. But since then, we've had a winner of the World Championship using Inventor. We've had a winner of the World Championship using Onshape. We've had a winner of the World Championship using Fusion. We've had winners using all kinds of different CAD systems. And that really goes to show you that really it is more about the wizard than the wand.
Yeah, I mean, you sort of answered my next question there. So like your platform is intentionally CAD agnostic, right? You're really trying to help people build skills on on sort of a meta level. So if you understand these concepts, if you can apply this knowledge, it kind of doesn't matter, whether you have the $5 hammer from Ace Hardware or the fancy framing hammer. Like, you're going to know how to snap a deck together, right? Yeah, I like the wand and wizard analogy better, though. I should have just stuck with that.
No, I mean it's it's a trade. We're learning a trade here, right? And
Yeah.
so with the website, the kind of the big event at the end of the year is the World Championship, the tournament, the CAD versus CAD tournament. And it certainly is exciting to watch. But then the question becomes, well, how can I get better at CAD? How do I get good at CAD? And that's what the website lets you do. It's almost like a gym for people that want to
Yep.
get better at CAD. And what I mean by that is that, when it comes to our target audience, there's really three categories, but they all kind of funnel into the same category, which is CAD enthusiasts. So the first category might be somebody who's brand new to the world of 3D CAD. And that might be like you just got your very first 3D printer, or you just got hired for a job and they want you to learn 3D CAD. We're going to have challenges for you that let you take real world parts, look at a 2D drawing and turn that into a 3D model. And we've got tutorials that help you along the way. And it's regardless of what CAD system you're using. We have members from the community that are posting tutorials to help people get better at whatever CAD system they happen to be using. The second category of users might be somebody who's very familiar with one CAD system. Maybe they're very familiar with SolidWorks, but now they want to move over to Fusion. And so they want to kind of get like a one-to-one comparison. I know how to model this part in SolidWorks, but how do I model the same part in Fusion? And so we've got tools in the platform that'll help you try doing the same model again and track your analytics and kind of see how fast you are. And a lot of times, if you know how to do it in SolidWorks, it makes it easier to learn how to do it in Fusion because it's like, that there is a command that does this. Now it's just a matter of finding that command. And once again, you could watch the tutorials, you could watch the speed runs, you can even ask questions in the Discord to Fusion users so you can help find that tool. And then the third and final category would be somebody who's a CAD professional, already pretty high level user, but now they want to really refine their skills or kind of branch out into other areas of their software. Like maybe they never work with sheet metal and they just want to focus on doing some sheet metal models. Well, our library has over 200 3D CAD challenges, and they're categorized by the model type and categorized by the difficulty level. So you could filter by sheet metal models, or you could filter by 3D printable models, or whatever type of model it is you're interested in creating. And then you could really focus on learning that area of the software. And beyond that, because we've got tools that let you try again and try again and try again, this is where it kind of becomes like a gym where you're doing your reps, or where it becomes like a true trade, where it's like you only really get good at it by doing it over and over and over again. One thing that I've learned in using Fusion and going through these challenges is that a lot of times in Fusion, as soon as you begin a command, the parameter for what the size is of that feature, it just shows up on the screen. You don't have to click anywhere. It's just there. And so by doing these reps, what I've realized is that I could just begin the fillet command, click an edge, and then right away start typing in the radius of that fillet, press enter, and boom, I'm done. I'm ready to move on to the next feature. That's a lot easier than taking my mouse, moving my mouse over to the correct box, double clicking, moving around in that box, trying to click OK at the end. Like I don't have to do any of that. I
Yeah.
just click on the edge, type the radius, boom, move on to the next one. Well, kind of learning how the software responds to your input as a user is a huge benefit that our, higher level, more experienced users get from the platform, is that they're able to really refine those skills, put in the reps, much like going to a gym.
It's a good example of sort of the principle behind how we built Fusion in the first place. When I was learning it, I was thinking kind of from an AutoCAD mindset because that's what the sketch environment felt like, right? So, I would start with, okay, like this is here, it's got a dimension. I do everything fully constrained, it's all there. Then you move on to the next thing, right? And I was doing a demo for this webinar, and Dan Bannock from the education team was like, "You're doing it wrong. This is not how we designed this software. Do it dirty and quick first. Just sketch out what you think it should look like. Circle here, this thing, like, maybe that's a chamfered edge or whatever. You could even do that later, whatever. Just make the dumb thing. Then you go in and like start adding constraints and parameters and stuff like that. So it's built that way. So you can just quickly run through, okay, fill it that. Yeah, that should be about whatever, like, quarter inch, half an inch, whatever, something like that. And you just go through boom, 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 boom. And then later, when you need to control the object and you might want different configurations, you might want some options there. Maybe you've got a different tool for this or whatever. You can go in and refine it and like assign parameters to things and name things and connect things, and all that stuff is there. So it's like, I don't know, what I've found with it, going from other CAD platforms that were more much more rigid in the first steps that you can quickly get ideas out there and then, kind of refine them and control them later on.
Oh yeah,
Um,
I mean that's exactly it. Like the phenomenon you're describing is really that phenomenon of going from, at least with traditional AutoCAD 2D, going from a non-parametric modeler to a parametric modeler. So
mm,
in that non-parametric modeler, it's like you sketch the first line, then you have to do an offset, and you got to make sure that the offset is in the right direction. Or like if you're making an L shape, it's like you type, the direction you're going in, and then the distance that that line needs to go, and then you turn on orthos, and then you just move the mouse up, and then type in the next distance. But once you type in that distance, it's like it's locked in. And so
yeah.
to your point, you're very much like on eggshells as you're doing that initial geometry, because once it's there, it's like you have to do a lot. You have to try to move a line. Now it becomes disconnected at the ends. Now you got to like move those endpoints as well. And, it becomes quite a bit of work where once you move into that parametric environment, now, exactly like you said, and Fusion does a great job of this. You're able just to kind of like, I know sort of what the shape is going to look like. So let me just draw that shape first. And now I'm going to go back in and add in the dimensions and like start refining that shape afterwards.
Yeah. Yeah. I mean, all of this kind of gets back to this idea of project-based learning. I mean, that's really what you're providing here, right? It seems like the sort of the zeitgeist has moved towards that over the years. Because I remember when I was learning CAD, maybe it's just YouTube is the what made the difference here. But like when I was learning, there was like a book, right? I had to like buy a book and go
Hmm.
through and like figure out how all these things work. And you're just going in and like, eventually you sort of get used to the vocabulary and you can learn that way. But like it was not a way of learning that was conducive to um, hitting the ground running quickly, like getting something done fast.
So
But what
when
you're
I was
doing
learning,
is, yeah.
we also had a book. It was very, I'm sure it was very similar, but the thing that stood out to me was that at the end of each chapter, there were these challenges. Like
Mhm.
now that did your book have that as well?
Yes. Yeah.
Like now
Yeah.
that you've learned this, now here, try to draw this. We're just going to show you the part and some dimensions. Now you try to draw it.
Yeah.
That
Yeah.
was always the part that I liked the most.
Hmm.
And everyone learns differently. And I'm not trying to say that this, that project-based learning is the absolute, like, this is how everybody should learn. But it felt like there wasn't enough of this out there that was structured, that was searchable, that was organized by difficulty level, and that just kind of let people jump right in. Like, you don't necessarily have to go through that book, as long as, like you said, as long as you have access to tools like YouTube, as long as there's tutorials that are readily accessible. And it was those challenges at the end of each chapter that I really liked. Like, it's
Yeah.
like, all right, now don't tell me how to do it. Let me just kind of figure out my way through it. And that's where I learned the most, because that's where I would be like, oh, you could, when you're making those lines, you could also type the dimensions.
Yeah.
That's pretty, the book didn't tell me that. That's pretty
Yeah.
cool. Oh, you could do
Sure.
the fillet, you could do the fillet here, or you could do the fillet there. I wonder which one's going to work better. You
Yeah.
know, try it.
Yeah, and you've got, I mean, you mentioned it earlier, but you've got CAD printable challenges, right? So go through your challenge, and at the end, I'm sorry, 3D printable is what I meant.
Hmm.
So you go through the challenge. At the end, you've got an object that's suitable for 3D printing, and it's something useful. So you showed us that little tray earlier that you use for
Yeah.
guitar picks. Yeah.
Yeah, so this is the very first challenge on the website. So we show you a 2D picture of this. We've got tutorials in there for Fusion, for FreeCAD, for several different CAD systems if you get stuck. And you try to take the 2D print and turn this into a model, and then you have to calculate the mass. So you
Hmm.
make it out of ABS, and then you can print it out of whatever you want. Obviously, you might make it in CAD out of ABS and then print it out of PLA or PETG or something, but you can print it out of whatever you want. But now, within just a few minutes without even signing up for an account, you kind of get to have some fun with it, and you get to see what it's like to go through that full process of creating the model and then getting that model off to your 3D printer. There's other cool models in that library too. Like we made this. This is one of the models in the library. So this is what I'm holding up here is a tool that you would use when you're drilling a hole in drywall and you want to catch the dust. It's a little
Nice.
dust collector, a dust catcher. And this is something that the 2D drawing is in the library, and then you could model it up, and then you'd have something that you could 3D print. I think people really enjoy those types of projects where they can actually hold something in their hand when they're done.
Yeah. Yeah. I mean, that on its own is really satisfying. I think it activates another part of your brain as well, because you're getting past this kind of virtual world. You get to actually hold a thing. I mean, the how ubiquitous 3D printers are now, I think is huge for people learning this stuff because, A lot of times, like, yeah, this might be a hobby, it might be something. I mean, it could be your day job too, and like it's so rare that you actually see artifacts, but now it's so easy to just, um, validate something in the real world quickly. And it makes me wonder, is this, you're starting to get into different territory when you do that, right? So you're not just talking about CAD, you're not just talking about, geometry in a digital space. It's there's other principles there. Like running a 3D printer, getting that right. There's all these other things that come into it, selecting materials, that kind of thing. Um, a lot of the tools we have on the Fusion platform and a lot of other, startups are doing all kinds of cool stuff now. They make it really easy to do things that used to be really expensive and really specialized. So you can go into Fusion and run a simulation on a part. We have a customer, Logan Olson. He makes putters, right? We did a tour of his shop a while back,
Nice.
and he uses the event simulation to kind of get a guess of what it's going to sound like when the putter hits the ball, and kind of what it's going to
Wow.
feel like. And like you look at the simulations, and he basically just turns it up to 11. It's like, let's pretend this is like, it's the club's going, 400 miles an hour or something like that. Like it's something nobody could ever do, but it exaggerates what's actually happening there. So then that gives him information about, like, you know, like I said, the sound and the feel of the thing hitting the ball. Um, Things like generative design, some of the simulation tools. I don't have I'm not very much trained in that. Like I am a little bit in, structures, finite element analysis, stuff like that. But I can give you, okay, I know what the forces are here. I know that this is down, right? I know how much this thing weighs. I can do some quick math and figure out, okay, there would be like so many newtons on this thing. Yeah, it's probably going to be spinning. The axis would be there. I know that it can't go here, here, and here. And now all of a sudden I've got like this part that, you know, you're not going to put it on an airplane, but you've got a starting point where if it's something that needs to be validated by an engineer, you can really quickly get into the higher principles of this stuff. So my question for you is that on the table? Are you working on things that are sort of beyond CAD and maybe a little bit more into the kind of conceptual side of things, more the higher level learning?
So I think that the a good analogy of this to always remember is that as an engineer, CAD is just one tool that we use, right? And so if you were an electrician, CAD might be like your wire snippers, and there's a lot that a master electrician can do with that one tool. If you're a carpenter, speed square, like CAD might be equivocal to like your speed square. There's a lot you can do with a speed square. Like there's a heck of a lot going on inside of that tool if you're willing to put the time in, put the reps in, and really learn how to use that tool. And whether you're, an electrician using wire snippers or whether you're a carpenter using a speed square, that time is well invested, and you're able to allow yourself to focus on some of the other disciplines of your trade. Because, CAD, like any trade, it is a very serious trade. There's one of the most common criticisms that we will get is that that we're not taking it serious enough, almost, that, like, if you use terms like gamification or leaderboard or speed modeling, that, like, you're not taking engineering seriously, and that's not the case at all. The members of this community are, they take a lot of pride in their trade, like any tradesperson would. You spend so much time trying to learn this trade, and 3D CAD and 3D modeling is just one part of engineering, and depending which type of engineering you go into, you're going to get more and more specialized. So, to your point of, are we going to get into simulation studies for velocity or rotational speed or anything like that? Probably not. This probably isn't going to be the platform like that. It's like when you go to the gym, you're going to the gym to work out all your muscles, but maybe that's because your job requires you to use those muscles to do many other things. Like maybe you're a firefighter, or maybe you're in the military, or, you're in some other very physically intense job. And so you use those muscles. Maybe you're like a jujitsu blue belt, and you're trying to level up through there. And so you're going to the gym to work out your muscles. It has nothing to do with jujitsu or any of the moves that you're going to learn. I think it's kind of that all those analogies pertain here. And it's important to remember that CAD is just one tool in the engineer's toolkit. and that CAD enables them to do many of the other things that they want to do with engineering, but it's not like the end goal. And what we're trying to do is we're really trying to enable engineers, first of all, to begin learning this new trade. If you're one of these newer CAD engineers, newer CAD designer, new to 3D printing, you got to know how to model up these parts. But we're also trying to kind of like get them to a certain point and then let them leave the nest. It's more of one of those things. And then when you leave the nest, that's when you would get into those more specialized fields of whether you're learning how to, be an AI wrangler where you're trying to do generative design, or whether you're trying to learn how to be a simulation specialist, or whatever it is that you're doing. CAD is just one tool. CAD is not engineering. It's just one tool that we use in engineering. And hopefully this gives our engineers a place where they can practice and they can refine that skill, they can get faster, and ultimately that helps them do more things with CAD, do things faster with CAD, but really kind of focus on why they got into engineering in the first place, on solving problems, and it kind of lets them solve problems and spend less time being frustrated about, how come I can't predict how the CAD's going to respond to my inputs? If we can alleviate that, I think that will be a mission successful.
Yeah. Yeah, I like that. I mean, you've got this, you're focused on this one specific skill. There's so many conversations going on right now about AI, and that's like kind of a big buzzword that gets pushed around a lot. But I think one of the biggest misconceptions about it is that it's going to replace engineers somehow, which is, I mean, it doesn't really make sense when you get down to it. It's going to make a single engineer more productive. You're probably going to need fewer engineers to solve a problem now because you've got some, machines that'll help you do the heavy lifting. But at the end of the day, you can't replace a an expert in something that's trained and experienced, that has the knowledge that's necessary to make decisions that are, they affect people's lives in a big way, where there's major safety concerns involved. And, it's not something you can just kind of, I'll push the make it an airplane part button and go put that in the airplane. Like, come on.
I think that where I can't speak that deeply on this topic just because like I don't have the expertise to really speak that deeply, but just from my casual observation, what I've seen is that AI gets you part of the way there. So to your point, it's like AI, you might be able to say, hey, I have these two parts, basically like generative design. I need to connect these two parts. I want to do it out of this material. And you input, like, here's where the two diameters are. And then it creates the connecting part. And I think that's great. But I think that more often than not, it's going to require some human hand intervention. You're still going to need to get in there. You're going to need to say, oh, you know what? If we're machining this, we're going to need to add a pocket here. Or if it needs to be assembled, we need to add a clearance hole so the tool can get through to
Yeah,
assemble it. So
exactly.
then you still need to know how to use CAD to do those steps.
Yep.
So what I like about, what we're doing and how we're training people, especially with the 3D printable stuff, like we showed this little tray earlier that's just a real simple rectangular hollow tray. But the cool thing is you have the model when you're done with this exercise. So you're in Fusion, you've modeled this up, it's parametric, and now you decide, you know what, I want this to be a little bigger. I want it to be for a soap. I want it to become a soap dish. So now you have the model, you can change those 3 dimensions and then send out that print, and now you've got your own customized version of this part. And I think that skill is so important, especially right now, because there may well come a time in the next few years where every engineer starts out with AI, and AI gets them halfway there or 3/4 of the way there. But they're still going to need to know how to get in and add those final chamfers and add those final pockets and make the thing machinable or make the thing, assemblable or whatever those final skills are that still kind of require some human intervention. And so you can't just rely on it to take you all the way there. If you just, if you go into a 3D model generator today and type in like, make me a gear, it's probably not going to have the correct diameter. It's not going to have the correct toothing. It's not going to have the correct keyway. And you're still going to need to know how to use 3D CAD to make those final touches.
Yeah, there's also the gear is a good example because there's also, crystallized knowledge there in individuals that know a lot about gears and gear ratios and stuff that, wouldn't necessarily be there in something that's automated. One of the things you learn early on there that's super counterintuitive is you don't want your ratios shouldn't be 12 to 24, for example. You actually need it should be 12 to 23, right? Because
Off a little bit.
then you're not hitting the same tooth over and over again, right? Like
Yes.
you get like, what I forget how the math works there, but like,
Yeah, but
way more life.
Yeah, but the AI says 12 to 24 is optimal. Because like
Exactly.
it just doesn't it's not accounting for like the fact that one of those teeth might be slightly out of spec.
Yeah.
So
Yeah. Yeah.
that is just going to
Exactly.
keep wearing and keep wearing. Yeah.
Yep.
Yeah.
Exactly.
I think that as always, like when we're thinking about AI and where it's going and what it can do and what it can't do, I think that with regards to what we're trying to help people learn about in 3D CAD and in Too Tall Toby on the platform is that idea of like look like practice modeling real world parts. Go around and practice
Yeah.
modeling real world parts, and that way, if somebody hands you a napkin sketch that's not to scale, like nothing is orthogonal, nothing looks good. That is just a napkin sketch. You can look at it and you've now experienced so much practice that you could be like, okay, that's going to be an extrude. That's going to be a hole. I'm going to use a hole tool for that. I'm going to extrude this one with some draft. I'm going to add some chamfers around these edges and I'm going to fill it across the top and you should be good to go. We can 3D print this thing.
Yeah.
That's really the skill that I'm trying to help people develop is, looking at these, you practice modeling these real world parts in kind of like a controlled environment where I give you a proper 2D drawing or semi-proper. I kind of use my own, we call it the Too Tall Toby standard because I have, there's some limits as far as how much real estate I have, but it's semi-proper 2D drawing, fully defined drawing, everything you need, material specification, everything, and you practice modeling them over and over again. And that way, when you need to build a bracket for your shelf that's fallen down, or you need to build a thing that goes, I just built something here. You notice there's no keyboard here because I drew up and 3D printed a little bracket underneath to hold my keyboard on my
Yeah.
desk. Like whatever it is that you need, whatever new bracketry or item or hinge or whatever it is, cup holder for in the car. Well, now you've got all that experience practicing and you can kind of visualize that and you can kind of hand sketch it up yourself and then you can turn it into a 3D model, turn it into a 3D print, and you're good to go.
Yeah. I'd really like to see you guys work with one of our tech partners, Xometry. I think you mentioned earlier that you were talking to him.
Yeah,
Obviously
so
going,
big news. We'll announce it here on the podcast. So we got the World Championship of 3D CAD Speed Modeling 2025 is coming up. So last year it was won by Rambro's Workshop, who's a Fusion user. Shout out to Rambro's Workshop. Yep, and makes all kinds of cool like excavators and stuff like that. Like he's a fantastic guy, very very skilled user, and obviously skilled enough to win the World Championship. So now we're back around the annual cycle, and now we're back to the World Championship. And Xometry is going to be sponsoring the tournament, and also is going to be doing some co-commentary with me
oh,
during the
cool.
tournament.
Oh,
So
that's great.
what'll
Yeah.
happen is we'll show a 2D drawing to two of the runners at the same time. They might be using the same CAD package. They might be using different CAD packages. They're from all over the world, and at the same time, they're gonna look at that drawing and they're gonna immediately start modeling it in their CAD package. They're gonna share their screens. We're gonna live stream that. Everybody's gonna be able to watch the live stream together. The chat will be able to commentate, and myself and the co-commentator from Xometry or whoever it is. I think it's gonna be Joel from Xometry, but
Uh-huh.
whoever's in the booth with me that day, we commentate on the action, and we try to make it interesting for the audience, and we talk a little bit about maybe how we would have done it or what they're doing, and kind of it's a lot going on, and it's a lot of
Yeah.
fun to watch, and some of these guys are so fast. I mean, most of the rounds only take a few minutes, 5 minutes, maybe 10 minutes if it's a really complicated model, but most of them take about 5 minutes, and you just can't believe how quickly these guys can go from a 2D drawing to a fully defined 3D model. It's absolutely amazing to watch.
So what's your plan for the future of the platform? What's next?
I think that for the future, some of the big things that we have on the horizon that we're very excited about is we want to start doing live in-person tournaments. All the tournaments we've done so far have just been for online. We do live streams through YouTube. We would love to get at a conference and do a live in-person conference and do some tournament action there, get some people together in person. And kind of what goes hand in hand with that is that next year we're really trying to put together a live conference for the Too Tall Toby community. And I think that what would really be amazing would be if at that live conference, if we could get all the past champions together and have like a battle royale, battle of champions, and see who amongst the wizards can become like the wizard king. I think that would be like the ultimate showdown. So those are some big things that we have planned for the future. Doing live tournaments, getting together at an actual conference, doing live tournaments, and then of course having our own conference next year sometime.
Nice.
Yeah.
Yeah. All right. So now is your chance to tell us where to find you.
Well, guys, if you want to find us, you can find us at tootalltoby.com. That is the website. When you go to the website, there will be links on there to get you to the Discord. If you want to come hang out on the Discord, you can try the first model totally for free without even signing up for an account. If you like it, then you can sign up for a free account and you get limited access. And then if you really like it, you can unlock the entire library. Over 200 challenges, categorized by difficulty, categorized by model type. And it's really a great place to go if you're trying to either learn or refine your 3D CAD skills. I'd say beyond that, you can visit us on youtube.com/TooTallToby, and that's where you're going to find all of the live streams for the upcoming World Championship of 3D CAD Speed Modeling 2025. And we are very excited. If you go to tootalltoby.com/tournaments, you can see the qualification. The qualifications are over, but you can see we've got 5 or 6 Fusion users in there in the top 16.
Thanks for coming, man. Great conversation. I really hope everybody goes and joins your platform. I'm about to do the same. I'll probably be on there this weekend.
Awesome. Thank you so much for having me here today, and good luck. I know you have Autodesk University coming up, so good luck with that. I don't know if it's going to happen before or after we release this episode. So either way, good luck, man. I know you're going to crush it.
Hey, everyone. Don't forget to like, comment, and subscribe to our YouTube channel to stay up to date with all things Shop Talk. If you're ready to try Fusion for yourself, find the link in our description.